sketch the graph of a function that satisfies the given conditions. So that's going to be a point, f of 0 equals 0. And then the f prime numbers where they equal 0, those are going to be critical numbers. So, critical points, I put them in red and on the dashes. Because out of that and all the information, we can get that the local min is at x equals -2. And the local max will be at x equals 1 and 9. And we can also get out of this that will be somewhat of a horizontal asymptote, and then the limit as x approaches 6 when it goes to negative infinity is going to be a vertical asymptote. When f prime is less than 0, those are all going to be decreasing. When f prime is greater than 0, it's all increasing. When f double prime is greater than 0, it's going to be concave up. When f double prime is less than 0, it's going to be concave down. So you got to keep all that in mind when you start to sketch the graph. So personally, I do it in pencil. So you think anything before -2 is going to be decreasing and concave up. So that's going to look like this. But it's not going to be exactly to -2 because somehow we have to stay from -2 to 1, we have to increase, so it'd have to be up, but it still needs to go concave up, so we can't exactly do that, and also we can't exactly do this and also go through that point, so you can't do that, so I erase that, but you can go decreasing and concave up further down and then increasing concave up until the point 0, 0, and then for 0, 0 it's still going to be, or now it's going to be concave down, but from 0 on, from -2 to 1, see it's increasing, so we're still going to 1, it's going to increase, but be concave down now. So it's going to increase, but be concave, sort of make it concave down. So increase but concave down. Mind you, we don't know exactly where the points are for the local min and max because they don't give us enough information for that. But then now we're at -1 with the local max, and from 1 on, it's 1 to 6, it's decreasing, but from 0 to 6, it's still concave down, so decreasing, concave down, all the way until 6. So we got that, and then we just make it decreasing, concave down, and it's gonna approach the asymptote but not touch it. So something like that. And then it's gonna be from 6 to 12 concave down, so the rest of it's gonna be concave down, or from 6 to 12 concave down, and then from 6 to 9 it's increasing. So we're gonna come from up here because it's increasing but concave down, so we kind of make it like that. And then from 9 to infinity it's decreasing, and from 6 to 12 is still concave down, so we got to worry about 12. So decreasing, concave down, it's going to look like this. But there's that vertical or horizontal asymptote right here. So it's decreasing, concave down until we get to 12, it turns to concave up. So decreasing concave up once we get to 12. So then you kind of make it concave up, but it can't touch that, so it just kind of goes on, and we don't really know much past that. So this is what the sketch of the graph would look like. So we're gonna sketch that. I'll make it a little bit darker. That's a rough sketch of what the graph would look like if it gives us all those conditions. So decreasing concave up, and then increasing, decreasing, and